Alright, so this is the final video that I'm going to record. This is section 11.4. This is on similarity theorems. Okay, so in this last section that I will cover, you guys will learn. So there are three different types of similarity theorems. There's the angle-angle triangle similarity theorem, there's the side-angle-side, and there's the side-side-side. Okay, so if we're to backtrack a little bit, so angle-angle triangle similarity theorem. This similarity theorem basically says if you prove that two angles are congruent to each other, so this pair of angles are congruent, these pair of angles are congruent, so this is just angle-angle triangle similarity. So that means these triangles are going to be similar to each other. Okay. So and then there's also the side-angle-side triangle similarity theorem. So basically this side-angle-side triangle similarity theorem says that if you find that two sides are proportional and you have a pair of included angles that are congruent, then these triangles are going to be similar to each other. Okay, so if you think about it, 2 divided by 4 is 1/2, 3 divided by 6 is 1/2. So these proportions are the same, and then these angles are congruent. This is by side, angle, side. The angle is included between the two sides. Okay, this one here, this last one is on side, side, side triangle similarity. And this is basically what we've gone over in the last couple lessons or so. But now you know what it's called. It's called side, side, side triangle similarity. Compare all the sides. This example is straight off one of the lessons that I did. So you can look back at the videos. You can look back at the videos for this one. But anyway, if you prove that all of these sides are going to be proportional to each other, the triangles are similar. Okay. Okay, so this next part. Okay, so I have here. Identify if these triangles are similar by angle-angle, side-angle-side, or side-side-side similarity. So this might take a little bit of what you learned in Module 5, but it's not terribly hard. Okay, so the way I designed these problems, they all should work, but you might run into cases where they won't work, and that's what we'll focus your next mastery quiz on, which will be quarter 4. Okay, but anyway, okay, so this part here, I see 3/9 is equal to 5/15, so that checks out. If you reduce these fractions, it's 1/3, right? So these angles are included between the two sides. This is side, angle, side similarity. I'm just going to abbreviate. Okay, this one here, we have two parallel lines. Two parallel lines. So we know that this angle is going to be congruent to this angle because they are alternate interior angles. We know that this angle here is congruent to this angle because they are vertical angles. Okay, so that means these triangles are going to be similar by angle-angle similarity. Okay. This one here, identify if the triangle is similar by all of these. This one, you're given a whole bunch of sides. This is side, side, side similarity. You could go ahead and calculate all the ratios. 30 divided by 42, 30 divided by 42, and the other one was 25 divided by 35. Go ahead and find all these, and they should be equal to each other. They should be equal to, I believe, 5/7. Okay. This one here, you can go ahead and find the ratio between these. So 52 divided by 84, 39 divided by 63. I have no idea what that is at the top of my head, but I think it's like 13 over something. Okay, well anyway, 13 over 21? 13 over 21. Yeah, okay. Anyway, you can go ahead and try to figure that out if you want. What I see is that this angle here is going to be congruent to this angle. So these triangles are going to be similar by side angle side similarity. This angle is included between the two sides. Side angle side similarity. This one here, okay, we know that this angle is congruent to this angle. Okay, angle X here, this angle is shared between both triangles ABX and YZX. Okay, this is angle similarity. Okay, because we identified two pairs of angles that are congruent. So this one here and this angle that is shared by the reflexive property. Okay, same thing for this one as well, I believe. Actually, well, this one is interesting. You could do side angle side, yeah, if you wanted to use this angle here. Or the other way that I believe you could do this is just look at all the sides. So you have this side, this side, this side. You have this side, this side, this side. If you went and go ahead, I'm not going to write out all of that, but if you were to compare all the proportions, they all should be proportional to each other. This is side, side, side similarity. Okay. Now you know what? Fine. 15 over 21 equals 20 divided by 28 equals 40 divided by 56. Okay. But later on, when you guys will have your mastery quiz on this, you guys will be expected to actually calculate these proportions. I'm just telling you that these should work. Okay. Let's go over to the examples that I'll go over in class. Okay. So I believe I have these three examples for to go over in class. Okay. So here, let's see. What I have here is this angle here. Yeah, it's given in the diagram. Angle RSV is congruent to angle T. Angle R is shared between both triangles, so angle R is going to be congruent to angle R by the reflexive property, which is what I just said earlier. So what I know here is that this angle is congruent. This angle is shared between both triangles. So this is by the angle similarity triangle theorem, yeah, triangle theorem, whatever. Yeah, so triangle RST. What the heck? I think that should say, I think that's an error. I think it should be RSV. RSV is similar to RTU. Okay? So in order to solve for RT, you're trying to find this length here. So if you want to solve it by using a proportion, this is what we applied last class, or if you can look at the online lesson. So this side, so let's see the way the book maps it out. RT, it does the big and then the small. This is going to be 10. And it is the other big side, so RTU is, this one is the bigger one. This is going to be 12. SV is the smaller one. This is going to be 8. So if you went ahead and solved it, this is 8RT equals 120. This is your beautiful butterfly. Solve for RT, and this is 15, I believe. So this is just divided by 8. Okay. This one here. Builder was given the design for a triangular roof as shown. Explain how he knows that a triangle AED is similar to triangle ACB. Okay, so what I see here is this. These are two parallel lines. So you can think of this as the transversal that cuts. The transversal that cuts the two parallel lines. So you could say that this angle and this angle here are called corresponding angles. You could even say that this angle and this angle here are corresponding angles. What I'm going to do is, instead I'm going to say this angle here is shared between both triangles by the reflexive property. So therefore, if the part says explain how he knows that the triangles are similar, so the triangles are similar by angle similarity triangle theorem. I'm just gonna abbreviate. Triangles are similar by angle similarity. Okay. In order to solve for AB, this is basically what you did earlier. So if you want to set up the proportion, you want to be very specific. AD divided by DE equals AB divided by BC. Okay, so AD is 6, ED is 9, AB is just there, CB is 15. Do your lovely butterfly. Okay, so this is going to be 15 times 6 is 90. Then 9AB divide by 9, you get 10 equals AB. Okay, so that's how you solve for AB. Okay, this next one here. Okay, so this is the last problem, and then we are good. Okay, so this one here, what I see is the side lengths. We have 3 pairs of corresponding side lengths. We're not given any corresponding angles, so this is 0. So our goal is to try using side similarity. Okay, so if we were to look at this, LM is 12, GH is 8. So that is 3/2. This next part, MN over HJ. So those sides are proportional, so MN is 15. JH or HJ is 10. This is also 3/2. Okay, so if I went to do the other one, what haven't we done? Let's see, we did LM, we did MN, so we didn't do LN. Okay, so this one is going to be LN, and then this part here is going to be GJ. Okay, so LN is 6, GJ is 4, this is 3/2. So therefore, these triangles, we'll just call it GHJ, is similar to LMN by side similarity. And since you're given all 3 pairs of sides, you do not need to check for those congruent angles. Yep. But let's say you were given this angle is congruent to that angle. That instead would be angle side similarity if you were to take these side lengths out. These side lengths out. Okay. And that is pretty much it. Yes. Finished. Alright. Yes. Please look at these, review these videos before I give you the Module 11 test. Yes, so hopefully you guys do something when I'm gone in Nashville. But good luck, and basically what we'll do is we're gonna review in the last day, in the last week. Use 1 day for review. Finally, we'll take the test, and quarter 3 is finished. Okay, see you in class very soon. Bye bye.